So what a lovely brand new day, right? This day will not come again in our life. Yes or no? The time which is past only keep at the back at the center. That is sitting posture, right? Good. Um, there's a, what is I say to go and sit with the place which is assigned to you. Children, look at here. At first, what do we do? We will discuss yesterday's matter, and then there will be duty of today's presentator. Where's your spectacle? You use the spectacle? Like why? Yesterday, it was discussed mainly about atomic weight and molecular weight. Atom is the smallest particle of an element which takes part in chemical reaction. It is unstable. Atom is unstable, but molecule is stable. Atomic weight is simply the sum of number of proton and number of neutron present in an atom. If the atom contains 12 proton and 13 neutrons, suppose how many proton? 12 proton, 13 neutron, then its atomic weight A will be how much? Simply add it. How much does it come? 25, but we have to write AMU, atomic mass unit. So at least first 20 elements atomic mass or atomic weight must be set in mind. Let's recap. Hydrogen 1, helium 4, lithium 7. Check in your book, page number 252. Beryllium 9, boron 11, carbon 12. Check there. Carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23, magnesium 24, aluminium 27, silicon 28, phosphorus 31, sulfur 32, chlorine 35, argon 40, potassium 39, calcium 40. These things must be set in mind. Understood, Anna? Right? Atomic mass. Okay, children. Now, that is atomic weight. So, let's discuss about molecular weight. What is given here? What is given here? Molecular weight. A molecule contains two or more than two atoms, either of same element or different element. For example, NH4Cl. What is the name of this compound? Ammonium chloride. What is this? Ammonium chloride. NH4 is ammonium. So you just pay attention here what the teacher is saying. Youth Pariya, make that one straight and try to focus. Teacher is saying one thing and mind is somewhere else roaming here and there. We have to be situational. Just keep your hand up. If you are inside the class, involved in classroom activities. If you are in party, especially we are going to organize one picnic. In picnic, you should not think about reading and writing. Just dancing, offering in your favorite songs. Otherwise playing, otherwise eating. They provide delicious food also. Yes or no? But that will be discussed at that time. Now we are discussing molecular weight. So, how many atoms are present in this molecule? Do you know? 7. 6. How many are there? 6 atoms are there? 7 are there? No, why? Somebody is saying 6, somebody is saying 7. So, let's check here once. Nitrogen 1, hydrogen 4, chlorine 1. Means total how many are there? 6 are there. How is 7 became? You counted this 5. Remember. Now, how to calculate the a molecular weight of NaCl? First, we'll write individual atom N plus how many hydrogens are here? So 4 times H plus Cl. We have separated the atoms. Are you paying attention here? Miss Kritika, can you see? You can come about this side, otherwise, Isneha, will you go that side? You keep the right side. I noticed you are looking at your Zumra and Lika only. Okay. Because everybody must see this smart board, see? Smart school, smart board, smart students, smart activity. You have to remember. Now, what is the atomic weight of nitrogen? How much? 14. 7 proton, 7 neutron. That chart must be learned very carefully. Only observing here doesn't matter. You must remember those things. Plus 4. Hydrogen, 1. Plus chlorine, 35, because there are 17 proton, 18 neutron. Now, first of all, 14 plus 4 1 4 plus 35. Don't add, subtract directly, otherwise you'll be mistake. First multiplication work you complete, then read. Now, okay, children, you add these all. 14 plus 4, 18. 18 plus 35. See, such type distance are there. If you ask, I can tell immediately. 53. 53 AMU. We have to write atomic mass unit. It was discussed yesterday. This is just recap only, right? In this way, you have to find out. Okay. Next one is radioactive elements. What is next? Radioactive elements. How many radioactive elements are there? 37 elements. Out of 118 elements, 37 elements, they can emit either alpha rays or beta rays or gamma rays or all rays, and later on they change into other forms. So that type of elements are called radioactive elements. Here is given alpha. What is here? Beta. Here what is here? Gamma. And the process of emission of such particles is called radioactivity. What is it? Radioactivity. And yesterday we discussed this radioactivity was discovered by whom? Henry Becquerel. In MCQ question can be asked. Who discovered radioactivity? Question. I remember Krizal Khanka, Yud Pariyar, Henry Becquerel. And what is the correct answer? Krizal Khanka? Henry Becquerel. And who knows? You may discover some new things in future, and you may get that Nobel Prize. The most prestigious prize of the world is Nobel Prize. Please try, right? So you have to focus. A Nobel Prize.
For physics in 19. There is a for discovery of radioactivity.
Yes, that will be okay. In 1903 AD, he got Nobel Prize. Nobel Prize was started from 1901 to 3. Third year only he got this one, see. Yes or no? Till now, none of the person from Nepal has got Nobel Prize. Actually, in 2046, yeah, I think, yeah. In 2046 means in 1990, Nepal government tried. Nepal government sent the name of Girija Prasad Koirala. Whose name was sent? I think in that year or in 2064. I don't know, because maybe in 2064, because there was agreement between Maoist and Congress, and from Maoist Prachanda's name, and from Congress that government whose name was there, Girija Prasad Koirala, and they were nominated, or their name was sent for a Nobel Peace Prize, but they didn't get it. Have you heard the name of Nelson Mandela? Nelson Mandela has got Nobel Peace Prize. Okay, Nobel Peace Prize. Anyway, so today's presentation is from um, Biresh Maharjan, Biresh Biredi, hai. So he is going to talk about nuclear energy. Nuclear energy means this is the energy associated with nucleus. Associated with nucleus. If there is some sort of change in nucleus, now remember, right? If there is some sort of change in nucleus, some mass is lost. That lost mass changes into energy. That energy is called nuclear energy. So, nuclear energy can be produced by two methods. One is nuclear fission. Nuclear fission means heavy nucleus breaks down and forms lighter nuclei and energy is produced. Fission means breaking down. Nuclear fission means heavy nucleus breaks down and forms lighter nuclei. As a result, what is produced? Energy. That is nuclear fission. Another is nuclear fusion. Nuclear fusion is that condition at which lighter nuclei, see, hydrogen. So, yesterday a teacher asked me about isotopes. You can see here 1H1, 1H1. This is one atom of hydrogen, right? Here is 1H2. It is another atom or not? So, its atomic mass is, or atomic weight is 1. Its atomic weight is 2. So, these type of atoms are called isotopes. So, in nuclear fusion, lighter nuclei fuse together and form heavy nucleus and release energy.
This is conducted in sunlight.
So, this chemical reaction takes place in stars. Where? Stars. So, sun is one star. Yes or no? There are billions of stars in this galaxy. So, they release energy by nuclear fission. And here is given atomic energy or nuclear energy, and chapter will be completed. So, without wasting time, let's welcome on the stage our today's presenter. What is your name? Come. Biresh Maharjan, right? Okay. My first.
Namaskar and very warm good morning to you. It's me, Biresh Maharjan from class 9, standing in front of you to present nuclear fission. Nuclear fission is a process in which the nucleus of even atom, usually uranium 235 or plutonium 239, split into two smaller nuclei, releasing a large amount of energy. This process occurs when the nucleus absorbs a neutron become unstable and device, producing additional neutron and significance receive of energy in the form of heat. The replace a neutron can go on to trigger further fission reaction in a chain reaction. Nuclear fission is the basic of energy production in nuclear reactor, and explosive force in atomic bombs. It offers a powerful energy source, but also poses risks like radiation exposure and nuclear waste. Nuclear fusion. Nuclear fusion is a process in which two light atomic nucleus combine to form a evener nucleus, releasing a large amount of energy. Fusion
What you are reading? Just you.
occur at extremely high temperature and pressure, which provide the success energy to overcome the electrostatic repulsion between the positively charged nucleus. This process power star, including the sun, where hydrogen nuclear fuse to from helium in the vast amount of energy as light and heat. Fusion has the potential to provide a nearly limitless and clean energy source with minimal radioactive waste, but active and sustaining the com- condition required from controller fusion on Earth remain a major scientific and imagining atomic energy of nuclear energy. Atomic energy or nuclear energy is the energy released from the nuclear of an atom either through fusion or nuclear fission. In nuclear fission, heavily in um, nuclear shocks as uranium
If you're just point out in it.
uranium 235 split into smaller nuclear re- releasing energy in nuclear fusion. Lighter uh, nuclear shocks as hydrogen in is to place isotopes combined to form or evenly nucleus also releasing energy. Nuclear power plant use controller fission reaction to generate electricity, offering a high energy with low carbon emission. However, nuclear energy presents challenges such as the risk of accidents, radiation
Radiation.
exposure, and the long-term storage of radioactive waste. Thank you.
Right. It's okay. But where are the reactions? You didn't bring reaction. You just brought some letters only. And you have to practice before coming here. It's not the matter of just coming, reading and going. Understood or not? Next time your presentation should be much better than this. Okay? Please give me. So now you are not new. We have started this program from the month of Baisak, right? From grade 8. 8 also you have practiced. Now 9 also you are doing. Means always if you remain same, then what are improvement is there? So the person who is going to present must be well prepared and come. Whose duty is tomorrow? No, today. Next period, who is going to do?
Now chapter complete.
A chapter completed. Now next chapter is there.
Exercise one.
Exercise we will discuss. Exercise I will give today. They will do. Exercise will be given to other persons. Now after Biresh Fission is there to present. Yeah, she will present today. Next will she will be presenting. Understood or not? Questions does matter. That is exercise. The others will do. Don't worry. That is not your tension. Sorry. How? Every day I told you to send on Saturday or not? Did I say you to send on Saturday or not? Then why did you wait for your this Wednesday, Thursday, Friday? And who is after her? Yeah. Did you send? Why? When will you go? Friday. So these two girls they will get this whole exercise now. After this Ravishan. Did you send? Good. She has sent. So today they will get this exercise I will give them. Lazy type of girl. It means for you we have to give on Sunday. For you Sunday in Rajan Kumar, did you get? So I'll give no problem. Okay, so this exercise work will be done by this, or what to do? Shall we discuss then in next period? Today we'll discuss, but listen, you should not wait like that. This is name Allah Thakuri and this Aravandari. Saturday only you have to send. Understood?
But we gave this like Sunday.
On Sunday, did I give? Oh, I gave Sunday, and why didn't you send on Monday? I waited. Amish. And there must be full phase preparation, right? So he has already brought here these things. Nuclear fission and nuclear fusion. By this process, listen, by this process, energy is released. In nuclear fission, what happens? In nuclear fission, uranium, you can see here, in nuclear fission, you just check this, how nuclear fission takes place. Here written 92, 90 means it is the atomic number, chile, which is written down, that is atomic number. What is written up, that is atomic mass. Atomic number, atomic mass. So when uranium atom strikes or collides with neutron, then barium, krypton, these two lighter nuclei are formed, because atomic number of barium is 56, atomic number of krypton is 36, and again what is produced? Neutron, and large amount of energy is released in nuclear fission. You have heard about atomic bombs. In atomic bombs, this technology is used. Uranium is used when it is bombarded in some places. That uranium reacts, collides with neutron, and huge amount of it, energy, light energy, sound energy is produced. That energy affects. So America dropped 2 atom bombs. Nowadays also sometimes they drop small bombs in different places, right? That is also based on nuclear fission. But next one is nuclear fusion. In nuclear fusion, this was discussed in previous chapter also, in wave. Check it here. 1h1, 1h1. Down, the number is atomic number. Upper one is atomic mass. 1h1, 1h1. Innermostly high temperature and pressure give 1h2. This is isotope. These two are isotopes of what? Hydrogen. Positron and energy. This chargeless electron is called positron. And 1h2, it is called deuterium. What is it called? Now listen, look at here. If I write here 1h1, this is ordinary. What is this? Hydrogen. 1h1. 1h2. What is this? Deuterium. Or it is also called heavy hydrogen. What is it called? Heavy hydrogen. 1h3. What is it called? Tritium. Pay attention here. Don't cycle. What the teacher is saying. Teacher is in his musty. Students are musty. And marks become susty. Very poor marks. 1h1, 1h2, 1h3. These are isotopes of hydrogen. So, lighter nuclei fuse together heavy nucleus. Again, heavy nucleus fuses with lighter nuclei. Light helium is formed. Unstable helium, because its atomic mass is 3. Again, energy. See, energy. Large amount of energy is produced or not. And again, that this one, 2He3 plus 2He3, enormously high temperature and pressure gives stable helium, hydrogen, and energy. So here, lighter nuclei fuse together and form heavy nucleus. In short, 2H1, H1. So how it is written, you have to check. Enormously high temperature and pressure positron and this energy. Stars, they release energy by this method. Developed countries like Russia, Japan, United Kingdom or England, they release energy, they produce energy by nuclear fission. So, and the last portion is given atomic energy or nuclear energy. The energy released during nuclear fission or nuclear fusion is called nuclear energy. So, nuclear energy is beneficial because we can produce electricity, we can make the house warm also, but it is harmful as well, especially the nuclear energy produced from nuclear power plant. There are some big buildings where uranium is used. From uranium, electricity is produced, and that electricity is supplied to different parts. But if there is leakage, then people may suffer from cancer also, may suffer from cancer as well. Okay, so this is the chapter which we have discussed right now. Everybody take out your book and go through the paragraphs very carefully, what is mentioned there and what you have understood. Make note so that it will be helpful to you. Okay, now reading and note making process. Are you ready? Yes or no? Come on.